Hello all, welcome back to the channel. Today we have an interesting problem. It looks very difficult, but once we understand the trick behind it, it's very easy. So let us look at what we have on the screen. So we have a summation of fractions. 1 divided by 1 times 2 plus 1 divided by 2 times 3 plus 1 divided by 3 times 4 plus 1 divided by 4 times 5 all the way till 1 divided by n minus 1 times n. So this looks a bit like a complicated multiplication and addition of those fractions. But if you look at the problem a bit deep, you'll see a trick here. So why don't you take some time and try to solve this by yourselves, and after you solved it, we come back and look at the solution. Okay, hope you're back with your solution. And first we'll try to solve this by brute force method. Right. So here it is asking for summation all the way till n. N is like a general number. So let us try to solve this with the first three fractions. So 1 by 1 times 2 plus 1 by 2 times 3 plus 1 by 3 times 4 plus 1 by 4 times 5. Okay, let's concentrate only on the first three. So the first one we can write as 1 by 2. The second one we can write 1 by 6. The third one we can write it as 1 by 12. Right? This is simple. So the entire summation becomes 12. This is 6 plus 2 plus 1. This will be 9 by 12. So 3 goes 3 times, 3 goes 4 times. So we have 3 by 4 here. And let us take 5 terms. That will be 1 by 1 times 2 plus 1 by 2 times 3 plus 1 by 3 times 4 plus 1 by 4 times 5 plus 1 by 6 times 5. This becomes 1 by 2 plus 1 by 6 plus 1 by 12 plus 1 by 20 plus 1 by 30. So what it becomes? So this becomes, I take this 60, so this becomes 30 plus 10 plus 5 plus 3 plus 2, which will be 45, 30 plus 10, 40, 40 plus 5, 45, 45 plus 3, 48, 48 plus 2, 50. So this becomes 50 by 60. Indeed, this becomes 5 by 6. Okay. But see, we can keep solving. If the number right now we took only 5, what if we take 1000? Shall we keep adding like this? Shall we keep doing this big addition every time a number increases? We can solve using brute force method, but we are not able to generalize this solution. We are not able to, as the numbers are increasing, this is becoming more and more complex. There should be a better way than this. So why don't you stop yourselves from this brute force method and see if there is any method much more elegant and much more generalizable than this solution. Think about it for 5 minutes and come back and check the solution, elegant solution, compared to the brute force method I'm going to give you now. Hope you have tried to solve this on your own and come up with an elegant solution here. If not, let us look at the trick that is behind this elegant solution. So how can we write the first term? The first term, 1, we can write as 2 minus 1 by 2 times 1. The second term we can write as 3 minus 2 by 3 times 2. The third one we can write as 4 minus 3 by 4 times 3. The fourth one we can write as 5 minus 4 by 5 times 4. And all the way we can write as, the last one we can write as n minus of n minus 1 by n minus 1 star n. Okay. If I have a fraction a minus b by a times b, I can write it as a by a times b minus b by a times b. Across of a and a here, across of b and b here, this becomes 1 by b minus 1 by a. Got it? So how can I write this first term? The first term I can write it as 2 by 2 times 1 minus 1 by 2 times 1. This I can write it as 3 by 3 times 2 minus 2 by 3 times 2. This I can write it as plus 4 by 4 times 3 minus 3 by 4 times 3. All the way plus the final one I can write as n by n minus 1 times n minus n minus 1 by n minus 1 times n. So each term we are writing it as two terms, a positive and negative, positive and negative, positive and negative, right? So if I simplify this a little bit more, it becomes 1 minus 1 by 2 plus 1 by 2 minus 1 by 3 plus 1 by 3 minus 1 by 4 plus all the way plus n minus 1 minus 1 by n, right? So every time, as I said, like this, a negative term, sorry, a positive term, negative term, positive term, negative term, positive term, negative term, and a positive term and negative term. But the trick part is the negative term in any term, the negative part in any term will be get cancelled by the positive term in the next term here. So this minus 1 by 2 get cancelled by 1 by 2. We can cross this off. Minus 1 by 3 get cancelled by 1 by 3. Minus 1 by 4 will be cancelled by positive 1 by 4 in the next. Similarly, this 1 by n minus 1 would be cancelled by the negative term in the preceding term. So all these in between terms, all these in between terms that are there here will cross off themselves. So the only thing that will be left will be 1 from the very first one minus 1 by n, the very last one. This will become n minus 1 by n. So in the previous method we did a lot of multiplication, a lot of addition. So it is solvable, but it is a bit complicated. But in this elegant method, we can finally say this entire summation will be equal to n minus 1 by n. So if n is, so if we take first 3 terms, it will be 1 by 1 times 2 plus 1 by 2 times 3 plus 1 by 3 times 4. So here it will become, n is 4 here. So it will become 4 minus 1 by 4 will be 3 by 4. Right? If it is like up till 1 by 4 times 5, this will be 1 by 1 times 2 plus 1 by 2 times 3 plus 1 by 3 times 4 plus 1 by 4 times 5, n will be 5. So this will become 5 minus 1 by 5. This will be equal to 4 by 5. So if you want all 1000 term summation, that will simply become 999 by 1000. So compared to the brute force method we have seen before, this is much easy. We need not do all this complex additions and summations. If you're more interested in tricky math like this, please subscribe my channel and like my content. See you in the next week. Thank you.